Hello and welcome to another Math Cats episode where we're talking about grade 10 math. We are using IXL to generate some questions for us to help our discussion. Feel free to explore that or use any other platform or book that you can get questions from to make progress, because we do need to practice more than what we're doing in this video. We are going to talk about systems of equations. Let's have a look here and use this example to illustrate what we're talking about. So we are looking for the values of x and y so that it satisfies both of these equations. Now, the first one for our first example is very simple. It doesn't have an x in it, but that's not going to always be the case. With substitution, I want to isolate one of the variables, whichever one is convenient, using one of the equations. Now, in this example, this one is already isolating y, and it says it's -4. That's true throughout. There is only one y value, well, in these simple examples. So I can use that and plug the -4 in for y in the second equation. That then becomes x minus 4 times the -4 that was that was y. And it equals 7. I'll simplify a little bit here, not skipping too many steps. -4 times -4 is a positive 16 equals 7. And now I want to solve for x, subtracting 16 on both sides, and we get x is equal to -9. So let's type that in there. X is first, remember, -9 and -4 for y. Now, the basics of equations, we won't explain simplifying equations that much. It's more having to solve two equations simultaneously. Let's submit that. Well done indeed. Here we have another one. This time they're very kind. They're giving us a simple second equation. So I can use that and plug it in this time for x. So x is 6 and -5 times y equals 16, and I have to solve for y. So I can subtract 6 on both sides to get -5y equals 10. Then I'm dividing by -5 on both sides to get y equals -2. Plug that in, and hopefully the next one will be a little bit more general. X is 6, we know, given to us directly from one of the equations, which is very nice, just to get used to things. And y we found as -2. Terrific. All right. I'm going to pause here, give you a little commercial to tell you what we're all about, and then we'll get to something a little bit more interesting.
Welcome to Math Cats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.
All right, so for this one, we have something that's not completely trivial. They're not giving me any value in any one of these equations right away. I can choose, okay, well, this second one doesn't give me the value of y, but it does express y in terms of x. It says y, the value of y is always equal to the value of x plus 6. And I can use that information and sub it into the first equation. So let's call this equation 1 and this equation 2, and we can write sub equation 2 into equation 1. That means wherever there's a y, I can replace it with x plus 6. Well, I see a y right there. I'll replace it with x plus 6, and then the rest of the equation follows. So I substituted y for x plus 6. Now, I'm used to just moving all the variables to the left to have some consistency, but there are different small steps of simplifying this. The end result's all the same. Let's move all the x's to the left, which means I want to subtract by 3x on both sides. Not doing too many steps at once in case someone needs to see all the detail. Then on the right, I'll get just a 4. I'll still have this plus 6. And now I have 1x minus 3x's, so negative 2x. Then I'll also subtract 6 on both sides because I want the numbers on the other side to get negative 2x equals negative 2. Lastly, I divide by that coefficient of x, negative 2, to get x equal to 1. Now, you don't have to necessarily write that much detail, but some detail is good, especially as you're learning. Let's put the 1 in as we have discovered it. And now we can use any one of the equations to find the corresponding value for y. Let's use equation 2, for example, because it's the simplest one. I go for the simple one. And that tells me y is x plus 1. Well, x is now 1. So it's, sorry, x plus 6. X is now 1. So it's 1 plus 6, which equals 7. And we can put in the 7. But I do encourage you in the beginning to write everything as clearly as you need it, so that your teacher can see this perhaps, and you can review this much more easily than if you just put a 1 and a 7. Try and do it in your head. That's not the way we do it. Write everything out. Have something you can reference and you can see. The less you write down, the more you have to keep track in your head. And we don't need to do that. Let's submit that. We are keeping it up. Good. Next one here. I'll do one more, maybe a little faster, perhaps. We are looking at the simplest equation here. Well, they're both very similar. I'll use equation 1, and I see I don't have to rewrite it. They could have given me something like this for equation 1, right? Y minus x equals negative 5. They could have done that. And then I have to solve for one of the variables. But they did not do that. So they make it a little bit easier. I'll sub equation 1 into equation 2. Simply because 1 is a little bit simpler. There's no real reason because I have both. I could do it backwards as well. So this equation 1 says whenever I see a y, it's equivalent, exactly the same as x minus 5. So I'll put x minus 5 in place of it where I see it in equation 2. That then gives me this equation. Now I'll move all the variables to the left by subtracting 2x to get negative x minus 5 equals negative 8. I'll add 5 on both sides to get the numbers on the right. And I will get a negative 3 here. Then I'll divide by negative 1 to get x alone, and it equals 3. Then we can use maybe equation, well, I'll use equation 1 because it is simpler. Go for the simple option. To find the corresponding value of y, When x is 3, y is 3 minus 5, because I just plug in 3 for x, and I get a negative 2. So now I'm ready to put in my answer. X is first, 3. Y is next, which was negative 2. Let's submit that. All right, let's do something that is a little step up where they don't give me the equations as easily. And that's really the only complication here. We can number this 1, 2. I just have to slow down and think about which one do I want to rewrite and how. So I look at these two. Equation 1 feels a little bit simpler to me and easier to isolate a variable. I could choose x or y because they're equally simple in terms of their coefficients. But if I imagine doing an isolation with the second equation, I'll create fractions. If I solve for y at some point, after moving things, I'm going to have to divide by 4, and I'll create a 9 over 4. If I isolate x, I'm going to have an 8 over 9 somewhere. So I don't want to create fractions when I can avoid it. So I'll take equation 1 and write it by solving for x, adding y on both sides. So x is equal to y plus 11. Then we can take that and substitute it into equation 2. Now x is the same as y plus 11. So wherever I see an x, and as I write my equation, I see it right there, I sub in y plus 11. Then the rest doesn't have an x, so I'm just copying it. Copy that, copy that. So that's when I substitute in x as y plus 11. Now I have to multiply the negative 9 in to get negative 9y. Negative 9 in there will be minus 99. I still have the minus 4y. I still have the negative 8. So let's put the like terms together. The y terms, negative 9 minus 4 is negative 13. Y minus my 99. I don't want to skip any steps. I want to be sure of what I'm doing at every step. The less I write down, the more I have to do in my head, and things get all jumbled up in there. Take the risk out of it. I'm going to add 99 on both sides because I want to move the numbers and isolate the y term. So negative 13y equals negative 8 plus 99 is equivalent to 99 minus 8, which is 91. And then positive. And then I have to divide both sides by negative 13. Isolating y on the left and having negative 7 on the right, because 7 times 13 is 70 plus 21 is 91. But feel free to use your calculator if you need to. But for these 2-digit numbers, I'd like to try for personal development and keeping arithmetic somewhat sharp, try and do it in your head. Even if it slows you down, it'll just get worse if you run to the calculator for little things. If they're into the hundreds and thousands, okay, fine. But for the little ones, try and practice your arithmetic where the opportunity is. So I have a negative 7 for y. I might as well type that in. Why not? And now I'm going to use either this equation or the rewritten equation 1 to find the corresponding value of x. Which one is the simplest? Well, this rewritten equation already has x alone on the left. So I'm going to use that and simply plug in the value of y as negative 7. Then I get my plus 11 there to get x equal to 4. So I just have to think a little bit, look at the equations. Which one's the simpler one? Which one do I want to use to solve a variable? And then slowly write things out and go from there. X is 4. It's all just a matter of taking your time and not expecting yourself to do this in your head. I can't, and that's okay. That doesn't mean we can't do this. Excellent. Oh, we have a challenge zone? Well, we can't say no to that. But it's kind of more of the same. You see, there is no more challenging things, really. That's the good news. So I'm going to actually leave. Don't be intimidated by the challenge. It's not a challenge. It's exactly the same thing. I'm going to leave this to you because we don't want this video to be too long. See if you can follow the exact steps we did last time. I'm going to look at that first equation and isolate x. That's the easiest one to use. And then write it out slowly. I know you can do it. Let me know in the comments what you think the answer is. If you have any other comments or concerns or questions, you are more than welcome. And we will continue next time. Until then.